Decoding Starlight, we're going to look at the colour of different stars. So, why do stars have different colours? And what does the colour of a star tell us about it? To begin with, we're going to look at light. And light exists in waves made up of infinitesimally small particles called photons. And each wave has a particular length, here shown from the top of one peak to the top of another peak. And natural light comes from sunlight to us on Earth. 97% of sunlight is made up of visible light, sometimes called white light, infrared, and ultraviolet. And visible light has a wavelength between 400 and 750 nanometers. Infrared light has larger wavelengths, and ultraviolet has smaller wavelengths than visible light. And all of those types of waves are all part of the electromagnetic spectrum. And on this diagram, you've got square boxes, visible light wavelengths in the middle of the sunlight box, with infrared and ultraviolet either side of the visible. To the right, you've got shorter wavelengths of X-ray and gamma rays, and on the left, you've got longer wavelengths of microwaves and radio waves. And you can pause to look at the objects which have similar sizes to the wavelengths of the different regions of the electromagnetic spectrum. And white light, visible light, is actually a combination of colours, mixture of them, and all joined together, we see them as white light. But if you split the sunlight, the white light, with a glass prism, the sunlight is refracted, bent as it passes into the prism, and again it's going to be bent as it comes out of the prism. And the longer wavelengths are refracted less, the reds, and the shorter wavelengths, violets and blue, are bent more. And here are just comparisons of three of the coloured wavelengths here. And here you can see the different wavelengths of the colours, X-rays getting with very short wavelengths, and infrared with a longer wavelength than red light. Now, how do we see light and indeed the colours? Sunlight enters the eye, goes through the lens, and is going to be focused on the retina, and there are rod and cone receptors on the retina. Now, if we're looking at something like an apple, so those goggle eyes on the brain there, they actually see light that is reflected by the apple. Other wavelengths from sunlight have been absorbed, and the light goes onto the retina and then through the optic nerve, and will then be seen as we translate it into red. And the cones, the C circle above, we will look at those more closely, and they come in three different wavelengths: L for long, and they're the red wavelengths; M for medium, the green wavelengths; and B for blue, the shorter wavelengths. And we have 7 million cones on our retina and 120 million rods which deal with dimmer light. And here you can see actually the wavelengths overlap a bit for the cones, with the shorter blue cones on the left, the longer red cones on the right. The dotted line, those are the wavelengths that the rods are actually being able to see. So here we have a picture from the Hubble Space Telescope of part of the Sagittarius star cloud, and lots of colours there. And where do these colours come from? So we have the blue ones, there's a star called Rigel, 12,000 degrees Celsius, and that's a bluey white colour. Our sun at over 5,000 degrees Celsius is yellowy white, and Betelgeuse is a cooler star at 3,000 degrees Celsius, reddish looking. And then you can see a table here with the types of stars given letters O, B down to M, and the colours and the temperature ranges. And you can pause to look at some of these. Do you recognise any of the star names? Don't worry. When you go on and look at Be an Astronomer, you'll see where they are in the sky and learn a little bit more about them. And here you've got a blue, yellow, red. The yellow star is like our sun, the blue star like Rigel, and the red star like Betelgeuse. And you can pause to look at the temperature and see that the brighter stars are the ones with the shorter wavelengths. And also looking at the colours in a different way of just looking at the ranges of the colours of the different temperatures of the stars. And specific stars, Aldebaran, a red giant, 15th brightest star in the sky, in the constellation Taurus, approximately 4,000 degrees Celsius. And then if we look at Betelgeuse in Orion, and you see a depiction of the constellation with the three stars in the middle, Orion's sword belt, and Betelgeuse as his right shoulder, and then there's Rigel down at the bottom, almost as his left foot. And so temperature of Betelgeuse is barely 4,000 degrees Celsius. And the other one that we'll have a look at, a bluish white star, Vega, in a constellation of Lyra, and 40 times brighter than the sun, but of course it's much further away, and its temperature is 10,000 degrees Celsius. It says Kelvin there, which is nearly 300 degrees more. And what can you do? You can discover a little bit more about stars, and there are some links there for what are stars, the spectra, and what you need to know to view the night sky.